Welcome to Lesson 29, Session 1, Explore, Classifying Two-Dimensional Figures. The learning target for this lesson is I can classify two-dimensional figures based on properties. To start, divide the shapes into two groups. Give each group a title to explain your grouping. Pause the video and put together your groups and then press play to get some ideas from me. So one group that you could do is shapes with a right angle, which would be numbers 1, 5, and 6. And the second group would be shapes without a right angle, which are numbers 2, 3, and 4. You can also have a group of quadrilaterals. Those are numbers 2, 3, 5, and 6. And the second group would be not quadrilaterals, numbers 1 and 4. Try it on page 587. Arrange the quadrilaterals shown below into a Venn diagram that shows a hierarchy of categories from most general to most specific. Label the categories represented by these shapes in your Venn diagram. So the three shapes we have here are rectangle, parallelogram, and square. Pause the video and do your work, and then you can press play to check. So my Venn diagram looks like this. Parallelograms are the most general category, so those go on the outside. Second is rectangles. All rectangles are parallelograms, so that fits inside parallelograms. And the third category, the most specific one, is squares, which all squares are rectangles and parallelograms, so that one would go in the very center. Number 1 on page 588, look back. Explain how you organized the shapes in your Venn diagram. The parallelogram is on the outer region because the rectangle and the square have all the attributes of a parallelogram. So rectangles and squares are subcategories of parallelograms. The rectangle is next and the square is last because a square has all the attributes of a rectangle. Number 2, look ahead. In the Venn diagram below, the red and blue ovals represent subcategories of polygons. 3 polygons are placed into the ovals, with one shape in both ovals. What property is shared by the 2 shapes in the red oval? So if we are looking at the red oval here, we have this right triangle and this equilateral triangle. So a property that is shared by both of those shapes is that they are both triangles. Letter B. What property is shared by the 2 shapes in the blue oval? So we have this equilateral triangle here and a square. And something that I know that those 2 shapes have in common is all of their sides are the same length. They all have equal sides. Letter C. Use your answers to part A and B to write subcategory labels for each oval. So the first subcategory label would be triangles. And this one over here would be equilateral polygons. Why is the equilateral triangle inside of both the red and the blue ovals? An equilateral triangle is both a triangle and it has 3 sides of equal length. Number 3, reflect. In a Venn diagram, what is true about 2 categories represented by ovals that overlap without one oval being completely inside the other? So we saw that in the last slide, the Venn diagram, where they overlapped, but they weren't completely inside the other. Shapes in the 2 categories each have some, but not all, of the properties of the other category. Your assignment for session 1 is the green pages 589 and 590.